All right, let's get back to coding. So since last time I changed my mind a little bit, I decided not to have any navigation state. I will just pass the arena in here, and I decided to make it depend on the level. Because I thought, you know, as long as I maintain this interface at least partially of the level, in the sense that like maybe a function like this, right? Then I don't actually care about how you implement it, right? And this pathfinding is going to be tailored to a tile-based map. So as long as that's what you have, as long as you can give me this, you can kind of respond to this function, right? So I ended up just forward declaring level here, because I actually can't make it depend on the header directly, because navigation is going to be used by entity, and then entity is used by level. So that would be a circular dependency, although I think, now that I think of it, I actually don't include that stuff in the headers. So it would work either way, but anyways, it's fine. I only need the pointer to level here. I don't need to know the memory layout. And here I include my level. Yeah. So now I think it's down to the nitty-gritty of doing the pathfinding. So as I mentioned, I want to start with a little bit of A star pretty much, and then transition that to theta star. Yeah, so what I'm gonna do is, honestly, I think I'm just gonna start writing this pretty much. Crazy, right? Okay. All right, so I think that's fine. So one question immediately is that these are float vectors, and we need to be in tile space, or it's already in tile space, but we need to be in integers to actually query the state of the tile. So we need to change that, both of those, to that. But of course we don't just want to jump, and we don't want to come to the center of the tile, not to this. So we'll have to like still navigate to that end place inside the tile, or like we'll have to like collapse that path into kind of any angle path. So I don't know. Okay, so I think for now let's just call like that, so that then I can do from equals v to I round f32 to I32 from f dot x and dot y, and then I do the same for 2 f. Okay. And then I need a bunch of stuff. I need the open set. So my level is of limited size, and I guess whenever we're going to be doing pathfinding, we're going to be like only pathfinding within loaded chunks if it becomes a continuous map. So we'll just limit it to those chunk coordinates. Yeah, so I need open set, which is gonna be basically a bunch of vector 2i's, I think. And I'm not gonna make it a heap for now. I'm just gonna search through it. So let's just make it an array on the arena. Arena push array, and no, don't zero it. It's gonna be too much. So just push it onto the arena. How much? Yeah, I don't know. Maybe let's just go into defines and do define navigation max open set. Let's just say 1024 for now. I don't know what's a good number. So that's the number, and then the type is v2i. And then for the rest, I think I'll just make arrays that are of the same size as the level, right? So for example, I'll call came from, I'll call that parent, and what it's going to be is a, I guess just i32 is fine. Also going to be an array parents. So for every cell on the grid, I want to specify their parent. So here I think we kind of do need to zero. Or no? No, because 0 is still valid, so we'll have to think of... We'll have to see if there's another way to determine if they're already initialized. But okay, let's push onto the arena level W times level H, number of i32s. And I think I will do... Does it just not save H score? Should I make that ints, the scores? So I would do like diagonals are 14 and straight line is 10 cost. I think, yeah, why not? So let's also make it i32. I don't know, I guess this should be an int. There's no difference, but I kind of like the idea that my indices are basically ints unless they need to be size t. and it's kind of a difference in meaning. So for example, inside level, my sizes are ints. My sizes are ints, but this is kind of like the actual values, so those are I32s. Yeah, I don't know if it's good, to be honest, but that's how I've been doing it. Fuck it. So let's just do, yeah, let's just follow this. I don't know, I don't remember how I did it before, if I had H score as well, but let's just have G score, which is also going to be pretty much for the whole map. And same for H score, I mean F score. Right? And then I guess I need to do, oh man, it's gonna be so slow with the open set, because I think for now I'm literally just gonna be like search by index for the place to add, and also search by index for the smallest one. So it's going to be O of n for both adding and getting. Right, so here we add to open set. Okay. So, all right, that's fine. So let's just do, let's do int open set count will be 0, and then we can do open set count plus plus equals to the first one, right? So that's from, and then we can do or yeah, okay, I can actually, when I remove, I don't care about the order actually for now, so I can keep it tight. But I think let's maybe do a function add to open set, and I guess let's just take open set itself and value. So then, I guess let's make a struct. Data and int count. Okay, and then here we're doing set data at set count plus plus equals to value. All right, and we can also do get, oh wait, so that needs to actually be yeah, it's not gonna be as clean because I need to intermingle my open set and the node storage, or like the parent scores. So I need like get least F score. Should I like store that shit in here too? Okay. So man, this is so annoying. Get least F score, nav open set. Okay, let me just, I'm having analysis paralysis. Nav open, kind of perpetually. Nav open set, and let's just take the pointer to scores. I don't care. We'll collapse it later. Set and F scores, get least F score, and we'll return v2i. So what I need to do is for int I was 0, I is less than set count I plus plus I plus plus least what do I call these? Least node and least score is going to be float max. And then we do if set data at I is less, okay, but that gives us a coordinate, or that gives us a vector, and that would be also cool here. Inline I32. Oh, see by here, these are I32s. It's so stupid that I'm worrying about this. Whatever. vec2idx, and I take the width, and I take a v2i v, and then I return v.x plus v.y times w. So I can do pi equals to vec2idx. Okay, I guess I also need the level width. Level width and this. And then I need to see if f scores at pi is less than least score. And if so, we set least node equals to this guy. And we set least score equals to this guy. Okay, that's fine. And another thing I want is void remove node. And I guess I'll search for it. Oh my god. I mean, ultimately this will be, he probably, last time I actually didn't do that. Like I said I would. But then it ended up not really being a problem as much. I mean, actually it did end up being a problem, but it never got to it. It wasn't the highest priority. But okay, that's the set, and let's just see the value, I guess. So we need to go through our list and if set data i.x equals to value.x and same for .y, then we do this. I guess I can just stop the loop. Okay. To remove equals to I. And then if to remove is greater or equal to 0, so if we found it, we say set data at to remove is going to be equal to set data at count I guess minus minus count. Right, so at count we have nothing. Reduce count by 1. So if we have like 3, we have 0, 1, 2. At 3 we got nothing. We reduce 3 to 2 and save it, and then use the 2 to put whatever was at 2 at, let's say, 1. Yeah, I think that's it. Very nice. Okay, so now there's one thing here, actually. Is open set empty? Let's just do it like that. Is open set empty? We just return whether set count is less or equal to 0. Okay, so while not is open set empty, open set, we do so. Okay, so while open set is not empty, we do something. Okay, I guess we can check if oh wow, actually already overloaded the equal operator, so I can actually just do that even here. So so we need to take that value, right? Node, I guess, let's just call it. Get least f score node. So pass the f scores. That's level w. That's the pointer to open set. So we do if node equals to 2, then I guess I will have I think that'll be just it, because we already know the parent or have the parent. So we can just break, and maybe we can say found path equals to false, equals to false initially. And here we set it to true. And then remove node. Remove from open set, pointer to open set, and the node. And then we have to go through our neighbors. So I will just return I guess struct. So we can have up to 8. So let's just do that, and then I can do count, and I can return neighbors. And then I can just go through my nodes. So last time I actually didn't just check if it's in bounds. I think I even checked if it's a valid node, and I just didn't even include a node if you can't walk on it, but maybe I don't know. I think I just do bounds now. So let's just walk through each potential neighbor and say if or what, maybe I do like that, -1 less or equal to 1 plus, sorry, that's y not I, and then same for x, plus plus. we can say also neighbors result. Just initialize, and then we do I guess we don't need the 0. Well, we don't need the 0, 0 itself, so we can say if not y equals 0 and x equals 0 and something else, if node.x plus x is greater than 0 or equal to 0, and node.x plus x is less than level w, and node.y plus y is greater than 0 or equal, and node.y plus y is less than level h. Okay. Then we do result dot nodes at result dot count plus plus equals to node, and then we return result. It's easy as that. So we can get our neighbors equals get neighbors level and node, for int neighbor I equals to 0, neighbor I is less than neighbors.count, neighbor I plus plus. Neighbor equals to, okay, the word neighbor now is like deconstructed in my head. Neighbor is going to be neighbors at neighbor I So we start with g-score of infinity. I guess I can just go through these. And the g-scores I equals int max, and f scores I also the same. Oh, we actually add, okay, so, okay. We can say G scores at vec to IDX level W from equals to 0. And for F score, we need the heuristic. I guess it's true that the nodes themselves could be just integers. That's probably not insignificant. It's quite a big difference. Yeah, I might change it later. So we need the heuristic. Which is just going to be the distance, but I think for my heuristic, what I need get H cost from to wait, H of start. Why is that? Why do we oh fuck, I'm stupid. Okay. Let's start to finish. Yeah. But how does this magically know this heuristic? I guess it could depend on multiple things. It doesn't specify. Okay, so what I want to do here, since I said it's 14, so diagonals I need to take as 14, and straight line I need to take as 1, or I mean as 10. So what I need to do is this. So basically we can take this distance between goals, so we can do like distance on y right, and we have dist on x, and then we see which one is greater, and or which one is smaller. So in this case y is smaller, so for that dist y we will do 14 times dist y, this will take min 14 times this plus 10 times max of dist y dist x minus this, I don't know, v minus v. Right, because that's also 3 here. Yeah, so it'll be something along those lines. All right. So we need I32 dist x from x minus 2x, and we need absolute value. Yeah, I have that. Not for ints. Int it's just this, right? And the reason it's here is that I don't want like that. This is in its own translation unit, and it's kind of temporary. But I think also you can do like intrinsics that it will replace this with, the calls to CRT. But either way, I just don't have to bring in the whole math library and such. Oh, where's that? Stdlib.h. So I can do abs I32, and then dist y is going to be abs I32 for y. And I can do if dist x is less than dist y, or what? I can do probably min dist equals min dist x dist y, and max dist equals max dist x dist y. And yeah, it's just this. Wait, if they're equal, max is going to give me y, and min is going to give me also y. Okay. Okay, and then what did I say? We need the min. We need I32 result will be min dist times 14 plus 14 times that plus 10 times max dist minus min dist. right? And that's our result. Wait, what? So oh, okay, so D is from current to neighbor. Okay. So I need also, I guess, the cost. Or should I just have a flag whether it's diagonal? Oh, no, it's fucking in an array. Oh, I need to put this into array. Oh, okay, I would need that either way. I guess cost. This is so annoying. Is dag. Eight. Is diagonal even. And then I just do why is that always so overly complicated? So this is like, if either of them are equal to 0, then it's not diagonal. Right? Wait. Does this even make sense? -1 on y and 1 on x. Okay. 1 and 1. 1 minus 1. And minus 1 minus 1. Oh, and then zeros. Okay, I think that makes sense. And there's 3 options here, 3 options here, so total is 9, minus 1 is 8. Yeah, that's right, I think. I think that's right. X, if x is 0 or y is 0, then we are not on a diagonal. But if it's not the case, then we are. Or should I just do cost? You know what, let's just do cost. It's a stupid thing anyways. This doesn't need to be generic. Get neighbors. So if that's the case, then they are not diagonal. So the cost is 10, otherwise the cost is 14. This is annoying. Let's just call this n. Let's call this n. Because neighbor I will be these ins I32s, I really need to drop that act, honestly. Neighbor I is going to be vec2 id x, level w, and neighbor. Right, so I take g-score of the current node, I do neighbor cost, and then I check if that tentative g-score is less than the already present g-score. And if it is, I set my parent for neighbor I to be the node I, set the g-score for neighbor I to be equal to tentative g-score, and set my f-score to be the score for neighbor I to be equal to so g-score is the cost of getting to the node. So we so what is f-score going to be? So f-score is to find the smallest. F-score represents the best guess, the smallest f-score. Well, g-score, so the reason why we are comparing g-scores for the neighbors is to see if we already saw that guy, that node, but now it's a faster way to get to that node. So we don't actually care to compare f-score there, we just care about g-score. Okay, so we got g-scores, f-scores, and then f-scores will be tentative g-score plus where's heuristic? Oh, so yeah, I wrote it, but I was supposed to use it here. Get h cost start or from and to, and then same thing, get h cost from neighbor to. And then if, let's do another O(n) thing. What should be? Is in open set. I know how stupid all this is. A lot of this could be collapsed, which I'll do. So if not in open set, the neighbor, then we do add to open set neighbor. And then we can look into returning result. So if found path, I guess we can have now path result, result dot found path equals to found path, and then if found path, then we do result path at result path plus plus, that will be something. Okay, and then we return the result. Oh, okay, there's one thing. I never actually check if that's even reachable. Okay. I think even with that, let's just test that, but not right now. I gotta go now. Maybe let's just see if it compiles. Oh yeah, there's a lot of shit. Oh, okay, this just needs to go. That needs to go. Return 2. Guess this has to be int max. Neighbors. Neighbors nodes. Oh. That's G-scores, that's G-scores, that's parents. Okay, so it's compiling. So let's stop here. I maybe will be back later today. Peace.